This video is kind of a combination of what we've been doing in the past couple days. We're going to take neutralization reactions that are incomplete. So that means we don't have equal moles of H plus and OH minus. And we're going to apply the idea of pH to it. So we want to know what the pH of an incomplete neutralization reaction is going to be. So to do that, there's a few things that you need to keep in mind. You need to do the following ideas. First off, you want to find the moles of H plus and the moles of OH minus that you use during the titration. You've got to do that separately. So nowhere can you use the titration equation because the moles are not equal. So you have to do a mole calculation with OH minus separate from a mole calculation with H plus. Second thing you need to do is determine the concentration of the ion in excess. This is technically the hardest part because there's a couple things you got to remember to do. And then finally, if you're asked for the pH, you've got to convert that concentration into the p-value and then ultimately determine what the pH is. So I've got, obviously, this is the organizer on page 1108. It's the back of the titration organizer that we've already spent some time on. So if you don't have it out yet, go ahead and pull it out because there's a sample problem that I want to work through with you and show you how it happens. And then there's one that I want you to practice, and I'll go over the answers with you once you get a chance to give it a shot on your own. So here's our example. We mix, notice what you have. There are no unknowns to put into the titration equation. You have the volume of both the acid and the base. You have the concentration of both the acid and the base. So big bells and whistles should be going off saying, hey, this means that I'm going to have something, I probably am going to have something in excess. You may very low chance of having both of those produce exactly the same amount, and then this would not be an incomplete titration. It would be a complete neutralization reaction instead of an incomplete one. But more likely than not, it's going to have one that is in excess. All right, so first thing we want to do, like I said, we're going to find the moles of H plus and OH minus. Okay, so like I said, you're using half the titration equation. So moles of H plus, we're going to take the volume times the molarity, and notice the volume has to be in liters because I've got to be able to cancel out molarity, which is moles per liter. I've got to be able to cancel that liter out with this liter. So I can't leave the volume in milliliters here. And then don't forget, you've got to convert it into moles of H plus, just not moles of acid. Now in this case, since I'm using HCl, it's just a 1-to-1 ratio. So if you forgot to do that, it works out okay. Not the case with the base, however, because you're using calcium hydroxide, which has 2 OHs. So to figure out the moles of OH minus, again, the volume of the base in liters times the molarity of the base times the mole ratio of hydroxide to base, which in this case is 2-to-1. So look at the numbers. Notice I'm going out reasonably far with my digits because I want to make sure that I see a difference. If you only go out to 1 or 2 significant figures, you may not see a difference. So you've got to keep going until you find a difference. So now that I know, now that I know how many moles, I can compare. So the second thing is determine the concentration, but I've got to figure out what's in excess. So if I look at my numbers, I can see that the moles of OH minus is slightly larger than the moles of H plus. So overall, my solution is going to be basic because I have excess hydroxide ions. All right, now second step, I want to determine the concentration of the ion in excess, in this case, the OH minus ion. Okay, and I'm going to do that by figuring out how many moles of excess I have. So I'm going to subtract the 2 moles. All of the H plus is going to react. So this is kind of like a limiting reactant problem. How much of the reactant in excess goes unreacted is essentially what we're doing. So I know that this many moles of hydroxide went in, but I know that this many moles of hydroxide reacted because they have to all react in a 1-to-1 ratio. So this much went in, this much reacted, this is how much didn't react. And then I have to figure out the volume. So I have moles, I've got to divide it by the volume. And here you've got to be careful. It's the total volume that you have to use because you've poured these two solutions together. Yes, you started out with 28.63 milliliters of calcium hydroxide, but you mix the two together. So in the end, you have a total volume of those two added together. So if you do this math, you wind up with a molarity of 7.78 times 10 to the negative fourth OH minus. Next step, to figure out pH, since we have OH minus, oops, sorry about that. Since we have OH minus, the first thing we have to do is figure out what the pOH is. So that's easy, right? Negative log of pOH, or negative log of OH minus gives me my pOH, so I wind up with a pOH of 3.1. And then I subtract that from 14 to get my pH. So in this case, the pH of the solution is 10.9, which makes sense. It's over 7 because OH minus is in excess. This is a basic solution. So 3 things you have to do. Figure out how many moles of ion you use. The tricky part here is you need to use liters. Okay, you can't use milliliters, you need to use liters. Then compare the two numbers, figure out which one is in excess, and calculate the concentration of that solution in excess, that ion in excess, using the total volume. So you get a concentration in moles of OH minus per liter of solution, or moles of OH plus per liter of solution if it's acidic. And then the last thing you want to do is convert from the concentration to the p-value. So here's another sample. You see it on the bottom of your organizer. Here's another practice problem. So I have the answer underneath the sheet. What I want you to do is pause the video, try and solve this one on your own. Pay attention to the number of moles. Look at what you have. You've got H2SO4 and NaOH. So pay attention when you're figuring out moles of H plus and moles of OH minus. Then pay attention to what the total volume is in liters to decide what your final concentration of that excess ion is. And I know it doesn't ask for pH, but go ahead and calculate the pH as well. Might as well practice that. Okay, so pause the video and do that. And then when you then start the video again. And when you come back, I will have the answer shown. So you're back and you've got hopefully a setup similar to what I have here. Volume in liters times molarity times 2 H pluses in sulfuric acid. Moles of OH minus is liters of base times molarity of base times mole ratio of OH minus. Once again, you compare these two and OH minus is in excess. So once again, we have a basic solution. So what's the OH minus concentration going to be? Here's the moles of excess, 3.4 times 10 to the negative fifth when I subtract these two. Here's the total volume. I'm going to add those individual volumes together. I get just a little over 100 milliliters. For a concentration of OH minus, that's 3.39 times 10 to the negative 4. pOH is going to be the negative log of that, so 3.47 minus 14 minus that gives you a pH of 10.53. So you've got a couple of problem sets to practice using that. Take your time, refer back to the examples, and you should have no trouble. Like I said, the 2 places you got to remember are how many H pluses and OH minuses, and use the total volume. Good luck.